HS 3.5, another one of the functions of the liver is another one of the detoxification functions is the elimination of ammonia. So where does ammonia come from? Well, when you're in the fasted state and you use your muscles, then the catabolism of the muscles produces amino acids, which are useful because they replace wear and tear, hormone synthesis, and for gluconeogenesis, they can be converted to glucose. But also, the byproduct is ammonia. Now, 95% of the ammonia is detoxified by conversion to urea in the liver, and then renally excreted. And some of it is incorporated into glutamine. However, if you have liver disease, then you're going to get an accumulation of ammonia in the liver. And what that's going to do is it's going to damage the astrocytes. You're going to get an accumulation of ammonia, not just in the liver, just generally you're going to get an accumulation of ammonia, which will damage astrocytes, which are related to neural function. And therefore you'll get something called liver flap. What happens is flapping hands. If you put your hands out like this and flap them up and down, that's liver flap. And what that's called is a hepatic encephalopathy. Encephalopathy means something to do with the nervous function. Hepatic means liver causes it. So the liver has caused ammonia to be built up, causing damage to astrocytes, causing liver flapping hands. So I mentioned that the liver synthesizes cholesterol. The cholesterol is then converted to bile acids and then conjugated to form bile salts. So how does that happen? Well, the cholesterol goes to the smooth endoplasmic reticulum of the hepatocytes, which synthesizes bile acids from the cholesterol. Then it's conjugated with amino acids to form bile salts. 0.5 liters of them a day. Then the bile salts are secreted to combine with lipids in the gastrointestinal tract, in the duodenum, to form water-soluble micelles. And the purpose of that is to allow lipid digestion and absorption. So let's think what happens if you have an absence of bile, an absence of cholesterol, or an absence of amino acids, or any of these in the chain. If you have an absence of bile, then you're going to get fat malabsorption, causing fatty stool, which is called steatorrhea. Urea means to do with stool, steat means fatty, right? So lack of bile causes steatorrhea. Now let's look at this. The cholesterol is turned into bile acids and then bile salts, but what's the point of conversion to bile salts if you have bile acids already? Well, bile salts are better. Why? They're more electrically charged, and therefore they're better at emulsifying fat at intestinal pH. So bile has a few functions, a couple of functions even. It's excretion of substances which can be filtered by the kidney, such as bilirubin, phospholipids, and salts and acids. So these are stuff that can't be filtered, that can't enter the kidneys. So for example, insoluble drugs, as well as I mentioned previously. And another function of the bile is absorption. So it allows the absorption of fats by forming water-soluble micelles, and it also allows the absorption, therefore, of fat-soluble vitamins A, D, E, K. How is the bile released? Well, remember the phases of the phases of absorption. Well, the different phases in the GIT. Well, you've got the basal phase, the cephalic phase, the gastric phase, and then finally intestinal phase. In the cephalic and the gastric phase, it stimulates the vagus and G cells to release gastrin. And what this does is it causes the relaxation of the sphincter of Oddi, which is the sphincter from the bile duct into the duodenum, right? And in the intestinal phase, what happens is that the fat which has entered the duodenum it stimulates duodenal I cells. Remember, I for fat, Ito cells store fat. So the fat in the duodenum stimulates the I cells, releasing cholecystokinin. I cells secrete cholecystokinin. And this essentially, the purpose of this is to cause bile release. And how are you going to do that? Well, you're going to cause the sphincter of Oddi to relax, and you're going to cause gallbladder contraction. So cholecystokinin does two things to cause bile acid release. Then what happens is that the bile salts, once they've done their job, once they've allowed them the fat absorption, 10% is lost in the feces as stercobilinogen. However, 90% will be reabsorbed into the enterohepatic circulation as urobilinogen. Entero means intestines, hepatic means liver, so the intestinal liver circulation from the intestines to the liver and back again.